Okay, here's part B. Let's start with question 1. I've got d squared times d cubed. That's the same as d times d times d times d times d. There's 5 of them. D squared times d cubed is d to the 5. AB squared times a squared b. So I've got a, b, b, a, b. There's 4 a's and there's 3 b's. X squared times d to the 0. If you remember, anything to the power of 0 is 1. 1 times anything is the anything. So 1 times x squared is x squared. 14 over 14 for part D, they cancel each other out. M cubed divided by m, the m's cancel, so I'm left with m squared is the answer. Now here I've got a times a cubed, which is a to the 4. Here I've got b squared times no other b, so b squared remains. 3 times negative 2 is negative 6. That is the answer. For question 2, the rectangle has a length of 3x minus 2 and a width of 2y plus 5. The perimeter is all the way around this rectangle. So I have two 3x minus 2's, and I have two 2y plus 5's. So it's 3x minus 2 plus 2y plus 5 plus 3x minus 2 plus 2y plus 5. So what I've got is 2 lots of 3x minus 2 added to 2 lots of 2y plus 5. This gives me 6x minus 4 plus 4y plus 10. The x and the y are terms I cannot collect. Negative 4 plus 10 is 6. So this gives me 6x plus 4y plus 6. If y equals 2, a simplified expression for the area does not use this expression. The area is 3x minus 2 length multiplied by 2y plus 5, which is the length times width. Now y is 2, which means we don't have to multiply all of this bracket out. If y is 2, I've got 2 times 2, which is 4, plus 5, that's 9. So I have 3x minus 2 multiplied by 9. I have 9 times 3x minus 2. 9 3's are 27. 9 2's are 18. That is the expression for the area, knowing y but not knowing x. Question 3. The area of this shape is length times width. That's 2x plus 1 multiplied by 3x. 3x multiplied by 2x plus 1 is the same thing. Multiplying this out, we get 6x squared plus 3x. For this shape here, if this is x and this is x, then that length there is twice x, as is this height here. So the area of this bigger square is 2x times 2x, which is 2x squared. However, we've got to take away this. So that's x times x, which is x squared. So 4x squared, take away x squared. There's 4 of them, take away 1 of them, which means I'm left with 3 of them. For question 4, consider the expression 4x plus 9 plus y minus 7z. List the terms. I have a 4x, I have a 9, I have a y, and I have a negative 7z. Stating the coefficient of each pronumeral in the expression, the coefficient of x is 4, the coefficient of y is 1, and the coefficient of z is negative 7. The constant term is the coefficient with no pronumeral. The constant term is 9. Question 5. Let's take each statement apart. 1/3 of A. Well, 1/3 of A is A divided by 3. Then I've got to add that to 2. The same thing would be true if we'd written 2 plus A divided by 3. The product of B and C is divided by 8. Well, the product of B and C is B times C, which we can write as BC. Divide that by 8, you get BC divided by 8. The sum of D and E is D plus E. You multiply that by 6, so we need the sum of D and E first, which is D plus E, and we're going to multiply that by 6. We could write D plus E multiplied by 6. Same thing. What we can't do is D plus E times 6. That's wrong because BODMAS would make us do this bit first. We need the brackets. The difference of F and twice the value of G. Twice the value of G is 2G. The difference between them is a subtraction. So F take 2G. Question 6. Simplifying these like terms, they're all K. 8 take 6 is 2, plus 3 is 5. I've got 2K plus 3K, which is 5K. Here I've got two x terms. 10x minus 4x is 6x. These are constant terms. Negative 5 plus 7 is positive 2. Here I've got two p values and I've got two q values. 9p take 2p is 7p. 8q plus 7q is 15q. D. I've got an A, an A, an AB, an AB, and just a B on its own. So, start with the A's. The 6A and the 5A gives me 11A. The B is simply on its own, so we're going to do subtract B. And the 4AB, take away one of the AB's, leaves me with positive 3AB, because it's 4AB subtract AB. There's 4 of these, take 1 of these. Question 8. Simplify the following. This is all multiplication. This is 3 times A times B times C times 4 times D. Long way around, if we rewrite all of that, we've got 3 times 4 times A, B, C, D, which is 12A, B, C, D. For part B, again, it's all product, but I can see there's an S and an S. So 6 times 8 is 48. There's only one R. There's only one T. But there's S times S, which is S squared. For C, There's a y on the top and there's a y on the bottom, so they will cancel each other out. 6 divided by 9 is the same as 2 divided by 3. We are left with 2x over 3z. Part D, on the top I have m, n, and on the bottom I have m, n, n. There's a squared term for the n, there's a squared term for the m. One of the n's will cancel each, and one of the m's will cancel each. This leaves me with m and n. 25 and 15 will cancel by 5. 5 5s are 25. 5 3s are 15. M is left on the top, n is left on the bottom. For question 9, simplifying these expressions, the common denominator is already in place. They are both over 7. So I can simply add the 6n to the 4n and get 10n over 7. I do not add the 7's together. I've got 6 sevenths plus 4 sevenths. That gives me 10 sevenths. Here, I don't have a common denominator. So I'm going to multiply both of these by 4. That gives me 7x over 8 take 4x over 8. I can now do the sum because they have a common denominator. 7x take 4x is 3x, and I still have it over 8 because 7/8 take away 4/8 is 3/8. For part C, again I need a common denominator. In this case I can't alter just one of them. 4, 8, 12. I have to have them as twelfths. To get this as twelfths, I times by 3. And to get this as twelfths, I times by 4. But what I do to the bottom, I have to do to the top. So this gives me 9k over 12, subtract 8k over 12. I now have a common denominator. 9 twelfths take 8 twelfths is 1 over 12, which we can write as k over 12. For part D, 6 and 9, if I double 9, I get 18. So if I triple 6, I get 18. So I'm going to times this side by 2, and I'm going to times this side by 3. I'll get 15a over 18 plus 16b over 18. I can rewrite that as 15a plus 16b over 18. For question 10, products, I don't really have to do anything unless I can look out for some early cancelling. In A, there are no early cancellations. So I'm going to go straight across the top. 7 times A times 3 times B gives me 21AB. And on the bottom, I get 8 times 5, which is 40. In part B, we can multiply straight across. However, I can see that the 5 and the 15 will cancel 1 to 3. The 6 and the 9 will cancel 2 to 3 if I divide both by 3. So I now have now I can multiply these across. I get 1 times 2, but it's k times k, which is k squared. 3 times 3 is 9. As an aside, because multiplication is commutative, I can actually rewrite the original expression 5k times 6k over 15 times 9. So what I'm doing is I'm reversing that. These aren't the same fractions, but the multiplication will work the same way. This is just to show you that 15 divided into 5 is 1 over 3. 6 over 9 is 2 over 3. So now I still get 2k squared over 9. When we divide fractions, don't forget there is that little trick. So divided by f over 8 can turn into multiply 8 over f. I'm only flipping one of them, I'm not changing the first one. So I get the same answer if I do 3e over 4 times 8 over f. I can cancel the 4 and the 8. 4 goes into 4 once, 4 goes into 8 twice. I now get 3e times 2, which is 6e, and I get 1 times f, which is f. That is my answer. For part D, again, I can flip, so 4x over 27 multiplied by 9x over 8yz. Now I can see 4 and 8, I can cancel again. 4 goes into 4 once, 4 goes into 8 twice, 9 goes into 9 once, 9 goes into 27 3 times. Now my x times my x will give me x squared, and my coefficients are now both 1. On the bottom, I've got 3 times 2yz, which is 6yz. That is my answer. For question 11, expanding these expressions, I'll do this quite quick. You can always watch the video back if you want to. This will be 4x plus 24. 2 times 3w minus 2 times 2. 6w minus 4. The negative 3 times the 5b gives me negative 15b. The negative 3 times the plus 4c gives me negative 12c. Negative 3 times 6 is negative 18 with the r. Negative 3 times negative 4 is plus 12. 3xy minus 15x minus 4xy. 3xy minus 4xy is minus 1xy minus the 15x. I don't need the 1. 2m squared times 4n. 2m squared times 4n. Subtract 2m squared times 5. 8m squared n subtract 10m squared. These have both got m squareds in them, but there's an n, so these are not like terms. I cannot do anything further with those two expressions, with the two terms in that expression. Sorry. For question 12, factorizing requires the highest common factor. 6 goes into 18 3 times. So I'm going to take the 6 out of there. H is only present in one of the terms, so I need the h, subtract 3. 6h, take 18, and I multiply that out. Here, 5 is common to both of those terms. So 5 can come out. There are no matching letters, so I can't take anything else out of there. I need 3m to get me the 15m, subtract 5 5s are 25, and I need the n to get me 25n. For C, 3 goes into both 3 and 24. However, if I take just the 3 out, I will need negative k at the front there, plus 8. That's okay. I'd rather write that as 3 times 8 subtract k. Now when I multiply this out, I'll get 24 minus 3k. Hopefully you can see that that's the same as negative 3k plus the 24. As that expression is written, this is the solution. The other thing I could do is take out the negative 3. If I take out the negative 3, I only need k here. It won't be plus 8, because I need it to be plus 24. It'll be minus 8. Now when I multiply this out, I get negative 3k, and minus 3 times minus 8 is plus 24. Minus 3k plus 24 is the same as 24 take 3k. For part D, factorising here, I've got 3 and y in both terms. If I take the 3 and the y out, I'm left with the x here, so I need the x there. Subtract 3 times 2 gets me 6, and y times y gets me the y squared. For part E, I can spot by inspection 6 goes into 18 3 times, 6 goes into 42 7 times. I'm going to take the 6 outside. There is b and there is c common to both terms. Open the bracket. 6 7s are 42, but I need the b to become b cubed, so I'm going to put b squared there. All of that times that will get me 42b cubed c. I need to subtract the 3 BC, and BC is already taken care of, so I'm going to close the bracket. 6BC times 3 will get me 18BC. The highest common factor of 8 and 10 for part F is 2. There is C and D in both, but there's only C and D squared and C squared and D, so I don't have any squareds I can take out. But there is a C and a D in both. Open my bracket. There's a plus in the middle. To get D squared from CD, I need to multiply by another D. 2 times 4 is 8. 2 times 5 gets me the 10. I've got a C and a D. I need another C to complete the expression. For the directed number, 4 plus 4, subtract 9. The negative will win, negative 5. Negative 7, adding 3, means I'm going to jump 3 spots up the number line. It'll give me negative 4. If I'm already down to negative 13 and I take 6 more away, I'll be even lower at negative 19. 10 plus negative 8, the addition of a negative number is the same as a subtraction, so that will equal 2. Negative 12 plus 25, the other way of doing either B and E is I can rewrite by switching around and I'll get 13. Negative 17 add negative 6 means I'm going to start with negative 16. The negative sign wins, and I will get negative 23. Part G, 38 plus negative 45 is 38 take 45. That's the same. No, it isn't. 38 take 45. You can think of that as 45 take 38, the difference between them, but the difference will be negative because the 45 is larger. This will give me negative 7. 40 subtract a negative 29. If the signs are the same, the sign changes. 40 plus 29 gets me 69. Negative 86 subtract negative 57 will produce negative 86 plus 57. I can, if I want to, that's the same as 57 take 86. Now, 56 take 86 would be negative 30. So 57 take 86 will be negative 29. Following products and quotients. 4 eighths are 32, and one of them is negative. 36 divided by 4 is 9, but one of them is negative. 9 times 5 is 45, and one of them is negative. 7 eighths are 56. So 56 over 8 is 7, but one of them is negative. 12 times 7 is 84. Both of these are negative, which means my answer is positive. 108 divided by 9 is 12. Both of them are negative, which means my answer will stay positive. For question 3, we have to pick apart the words, the phrases. The temperature one morning in Moscow was negative 2 degrees Celsius. During the day, the temperature rose by 4 and then dropped by 7. What is the temperature after the rise and the fall? Show your working. So, it started at negative 2. It rose by 4 and then dropped by 7. Negative 2 plus 4 is 2 take 7. 2 take 7 is minus 5. So after the rise and fall, the temperature was negative 5 degrees Celsius. Stuart sold 8 couches and 11 armchairs at the furniture store. He made a $10 loss on each couch and a $12 profit on each armchair. If he sold 8 couches, 11 armchairs, he lost $10 on each couch. We don't know the price of each item, but he sold 8 couches and made a $10 loss on each. So he lost 8 lots of 10. But he made 11 lots of 12. This is 121. This is 80. However, this is a loss. So he lost 8 lots of minus 10, negative 80. A $121 profit with an $80 loss leaves him with $41 overall profit. Evaluate the following. We're looking out for anything to do with BODMAS. Working from left to right, 10 plus, however, negative 4 times 6, brackets and multiplication first. 10 plus negative 4 times 6 is negative 24. 10 take 24 leaves me with negative 14. Negative 10, take 4 is in brackets, which means we do that before the multiplication. Negative 10, take 4 is negative 14. Multiply that by the 6. 14 times 6 is 60 plus 24, which is 84. The whole thing is negative. For part C, looking left to right along here, 13 addition is the last thing I'm going to do. 13 added 2. Now multiplication and division, I can just work left to right. Negative 4 times 5 is negative 20, divided by negative 10. 10 divided by 20 is 2. Negative 20 over negative 10. They're both negative, so my overall is positive 2. 13 plus 2 equals 15. That's my answer. For part D, I have a 9 plus a negative 12, but the divide sign takes over. So I've got 9 plus is first, but I've got to have a fraction here. That means my denominator is everything inside this bracket. I've got negative 6, take negative 2, but that negative 2 is multiplied by 5 first. So negative 2 times 5 is negative 10. So I have negative 6 subtract negative 10. Negative 6 plus 10 gives me 4. So I have 9 plus negative 12 divided by 4. 9 plus negative 12 divided by 4. 12 divided by 4 is 3. Negative 3. 9 plus negative 3 equals 9 take 3, which is 6. That is the answer. A is negative 3, B is 8. Negative 9 divided by negative 3 is positive 3. Both terms are negative. My answer is positive. If the signs are the same, the sign changes. A added to B divided by negative 4. This is A added to B divided by negative 4. This is negative 3 added to 8 divided by negative 4. This whole expression here is going to be negative 2. Negative 3 take 2 is negative 5. Negative 2 take away whatever's in the bracket divided by B. Negative 2 take away 5 plus negative 3 times 7. I do the negative 3 times 7 first, following BODMAS. 5 plus 7 3s are 21, divided by B. This is minus 2. Take away 5 plus negative 21. 21 take 5 would be 16. So this in the bracket is negative 16 divided by B. And B is 8. However, this is negative 16 divided by 8. So it's negative 2 subtract negative 16 over 8. This is 2 with a minus sign in front of it. Negative 2 take negative 2. Now you might think that's minus 4, negative 4. However, it's negative 2 plus 2, which gives me 0. Looking at my rules up here, squared means 2 of them multiplied together, cubed means 3 of them multiplied together. So evaluating these expressions, minus 5 squared is minus 5 times minus 5. A negative times a negative produces a positive. 7 times 7 is 49. So negative 7 times negative 7, they're both negatives, so the sign changes. So negative 7 squared is the same as 7 squared. Minus 2 cubed is minus 2 times minus 2 times minus 2. And minus 2 times minus 2 is 4 times minus 2. 4 times 2 is 8 with a negative sign. Minus 3 cubed is minus 3 times minus 3 times minus 3. 3 3s are 9. They're both negative, so the final is positive, times negative 3. 9 3s are 27. One of them is negative. Will the square of a negative number always be positive? The answer is yes. If you're squaring something, you're multiplying it by itself, which means I'm always going to multiply a negative number by a negative number. Negative times a negative gives me a positive. Will the cube of a negative number always be negative? The answer is yes. As above, if we square that negative number, we always get the positive. However, if I then multiply that again by that negative number, negative times a positive means the negative wins, but I have n times n squared, which gives me n cubed.